All right, welcome to our lesson here on isosceles triangles. I'm sure you're wondering what the deal with my eyes are. I've just got some allergy issues that have really bothered me here tonight, so hopefully that doesn't distract you as we go through this. I'm sorry about that. We first have to be able to talk about isosceles triangles. We know this about isosceles triangle. It's a triangle with two congruent sides. We've learned that already. The sides that are the two congruent sides are called legs. Kind of like the two sides of a right triangle are called legs. It works kind of like that here. The third side of a right triangle the third side of an isosceles triangle is called the base. The two non-isosceles sides are called bases. Notice that it doesn't mean the base is on the bottom. These two legs are the two isosceles congruent sides. The other side is called the base. Base does not, in geometry, mean bottom necessarily. The two angles at the base are called base angles. I'm not sure why they call it that exactly, but they're called base angles. Maybe because they're on the base side. I never really thought about it. But anyway, the angle opposite the base is called, these are the two base angles of these two triangles. It's called the vertex angle. And we would call this the vertex, this point up here where the two legs come together is called the vertex. So this is the vertex angle on this triangle. This would be the vertex angle. So we have these terms: legs, base angles, and vertex angle. So when we're talking about them, we need to be able to talk about all of those terms. The isosceles triangle theorems, these two things here is really what this whole lesson, what this whole section is all about. If two sides of a triangle are congruent, in other words, it's an isosceles triangle, then the angles opposite these sides are congruent. Well, what are the angles that are opposite these two congruent sides called? Well, this is talking about legs. If the legs are congruent, then the base angles are congruent. If legs are congruent, the base angles are congruent. So an isosceles triangle not only has congruent sides, it has two congruent angles. Okay, and we can flip this around. The converse of this says if two angles of a triangle are congruent, then the sides opposite the angles are congruent. So if you know base angles are congruent, then the legs are congruent as well. All right, so the deal with isosceles triangles, you have two congruent sides, you have two congruent angles. If you have two congruent angles, then it's an isosceles triangle with two congruent sides as well. So in this triangle here, if segment AB and segment BC are congruent, those two sides of that triangle congruent, that means that these base angles are also congruent. And if we knew the base angles were congruent, we could say the legs were congruent as well. That right there, folks, is it. That allows us to answer the next sets of questions. So these are, well, the next set of questions here is going to be 2/3 to what we're going to be doing here. Find the values of x. Well, here we have, in this first example, we have an isosceles triangle. You will note it's an isosceles triangle because of the two base angles that are congruent. Therefore, these sides here are congruent as well. So we can just simply set the lengths of those sides equal to each other, solve for x, and we get x is equal to 13. You can check your work, plug 13 back in, and make sure those two sides are congruent. The lengths of those two sides, if x is 13, are both 34. The variable oftentimes will be an angle. Well, this is an isosceles triangle, so these two sides are congruent. Those are the legs. Therefore, the two base angles have to be congruent. If this base angle is x, so is this other base angle. Those three angles have to add up to 180, so those two base angles have to add up to 110, divide by 2, 55. So subtract 70 from 180, divide by 2 to get x in this case. A different type of triangle situation here, we have two triangles together. If this angle over here is 2x, what is this angle opposite going to be? This a vertical angle, so if that's 2x, then this triangle in here is also 2x. We have two isosceles, or we have two congruent sides, so the base angles over here have to be congruent. Here's the vertex angle plus these two base angles will all add up to 180. So 6x plus 6, one of the base angles plus the other base angle plus the vertex angle equals 180. There's your equation. Get all the x's together, get all the constants together. We solve and get x is equal to 12. Plug those in. That makes this angle here, 2x is equal to 24. 6x plus 6 gets you 78. So those three angles better add up to 180. I'm pretty sure they do. I'm seeing this calculator and I stink at math in my head, but that's got to be 150. Yep, 180 degrees with those three angles. All right, go ahead and try these next four. Here, did you set these legs equal to each other and then solve for x and get x equal to 6? Here, did you say if these are the two legs, these are the two base angles? So if that's 65 degrees, so is this over here. So what does x have to be? In this case, 50. Two base angles congruent. The two sides opposite have to be congruent as well. Solve for that. Did you get x equals to 5? Base angles here with the legs. So if that's x, so is this. X plus 80 has to equal 180. So x ends up being 50. I'll be happy to explain these questions further if you need it, but hopefully you figured some of that out there as we went. So the questions on this side just continue. We got base angles that should be the same. Having an exterior angle, we have supplementary things going on over here. Once you know one angle in an isosceles triangle, you can figure out the rest. Because once you know what one angle is, well, you can figure out what the other two are. Give these a shot on your own, and I'll talk about them here in just a second. So on number 13, did you say that x plus 3x plus this other x has to equal 180 and get 36 as for x as a result? On number 14, did you realize that if that's 100 degrees, this angle here has to be 80, and this angle here has to be 80. 80 and 80 is 160. What's left? 20. 90-degree angle here. The other two angles, therefore, have to add up to 180 with that. 90, 45, and 45. This will be a very special triangle, a 45-degree, 90 triangle. Here, if this is 50, we can figure out what these other two angles are. These two have to add up to 130, so they're 65 apiece, which gets you 115 for the exterior as well. This isosceles triangle, if this is 70, we can figure out what these angles here are. They have to be 55. Which means that vertical angle there is 55, which will allow us to figure out what x is. Oh, that's interesting. Turns out that this x is the same as that 70 over there. You mean those are alternate interior angles that are congruent. That's fascinating. Here, speaking of parallel lines and alternate interior angles, did you go 62 degrees and 62 degrees right there? Ooh, isosceles triangle. If that's 62 degrees, this is 62 degrees. 62 degrees. Several different ways you could have gotten there. We can talk about those I want to see if anybody came up with any other ways of solving that. Another type of question here shows up in example 2. It's not quite as common of a question. It won't carry as much weight as what we just talked about. I wonder why they call them isosceles triangles instead of isosceles. Will you write that above this triangle over here, please? Isosceles. So this type of question here, given these congruent segments, name an isosceles triangle and then its two congruent angles. Given that if these two are the two legs of an isosceles triangle, so there are these segments here, AB and AE. Those are the congruent legs. So therefore, that's the triangle ABE. The triangle is ABE. A is the vertex, okay? A, B, E, A is the vertex. The two congruent sides are going to meet at the vertex. So it's going to be A, B, and A, E. I'd like to point this out to you. The two congruent sides both have the vertex in them, the A and the A. So there's the A. What am I saying? I'm talking about the other thing, actually. I'm sorry. The angles are the two. Okay, these are those answers. Hope that's making a little bit of sense. It was actually this type of question that I had just kind of rolling around in my head when I was describing the other. The other way of going about this is if we're giving these angles, what is the isosceles triangle if these are the two base angles? Well, these angles will meet, I think we can see, at S in this case. So the two vertices are V and Y. What's going to be the third letter of our triangle? They meet up here at S. There's VYS. So the vertex is S. So if we're going to name the two legs, those two legs will meet at S. They'll be SV and segment SY are the two legs. Okay? So I'll do number 24 with you. The vertex angle of this base angle, the vertex of this base angle is T. The vertex of this base angle is U. So the vertex of the triangle, the vertex angle, has to be at S. It's the one that does not have the vertex there. So we can say that this is triangle STU. The diagram supports this. I hope that you see that. And then the other two sides will be ST and SU. Those two sides will meet at S and U. Go ahead and finish 25, 26, and 27. These are the answers. These questions will end up not being a big deal if this was kind of confusing. I didn't do a very good job of explaining one of those at first. I'll do a better job the next time. Get some rest. We've got a lot going on.